Hi Guy, I'm Laurie from AI Elephant.
Hi guys, I'm Leo.
Today we're diving into a topic that feels highly sci-fi yet incredibly real: humanoid robots. Silicon Valley's top investors, engineers, and academics recently held a fascinating panel at the Alignment Conference. They weren't arguing about if robots are coming, but rather what they should look like. And critically, how they are going to make money.
Wait a minute, Laurie. I thought the ultimate form of robotics, what we see in movies, was the human-like robot that does all of our jobs. Is there still a debate in Silicon Valley? Isn't the humanoid form, as Elon Musk suggests, the one true final solution?
That is precisely the core of the issue. This episode's theme is, in the eyes of Silicon Valley, is the bottleneck for robotics technology technical, or is it commercial and capital related? We'll explore two philosophies, one chasing the starry sea of general humanoid form, the other focusing on the immediate Fordism that yields practical returns. The first main thread of this debate is a commercial philosophy showdown. Should a robot be created for a single specific task, or should it pursue the universal humanoid form factor? Investor Anand's viewpoint is sharp. He argues that focusing on revenue is more important for survival than chasing hype.
Revenue, that sounds very B2B, and frankly, a bit boring. But how does that manifest specifically? I mean, why would an enterprise client spend a large sum on a general robot instead of a cheaper, dedicated machine?
Anand uses a Henry Ford analogy to answer you. When Ford designed the transport system, he didn't base it on a horse or a person. He invented the car directly. Similarly, a dedicated vacuuming robot will far outperform any humanoid robot attempting to clean with a Dyson in terms of return on investment. In the enterprise market, a single task is often massive enough, and task-specific robots solve the immediate ROI problem sooner and more reliably.
Hold on! So the Optimus we imagine, which can cook, clean, and carry, is currently less effective than a sweeping machine. That is so anticlimactic. So what about Evan and the former Tesla Optimus team? Why do they remain so committed to the humanoid belief?
Evan represents the belief driven by first principles. They believe that although the path is long, the human form factor will ultimately prevail because the entire world, all the tools and environments, are designed for the human form. Once the technology is in place, the market for humanoid robots will be enormous, unlocking a much wider general service market.
Since humanoid robots are temporarily lagging in hardware and task specificity, what is their method for a comeback? It can't just be based on faith, right? Where is their true killer feature?
The killer feature comes from the software. From large language models, Stanford. Professor Yan provides strong support, pointing out that LLMs already speak fluent robotics. This has provided a clear line of sight to solving the long-standing problem of universally capable robotics.
What does speak fluent robotics mean? Does it mean the robot learns to work by chatting with the LLM? I don't quite grasp this logical leap.
You can think of the world as a contiguous block of text. The LLM's ability is to complete the story. When you connect the LLM to a physical shell that allows it to move, explore, and interact, you can ask it to continue the story, for example. I need coffee. Please go to the kitchen and make some. The robot no longer needs fixed software written for every single task. This ability allows a humanoid robot to be rapidly repurposed for various tasks, whether in hospitals, homes, or workplaces. This is the true leap in generality. To achieve generality, the hardware cost must be solved. Evan's team achieved a revolutionary breakthrough in dexterous hand design. They compressed the cost of a highly functional multi-degree of Freedom Hand, typically costing thousands, down to just $300.
$300! That is practically consumer electronics pricing. How did they manage that? What is the secret sauce in the design?
They adhere to a cable tendon-driven architecture. The philosophy behind this design is to understand the end result. The functionality of a human hand is designed to interact with surrounding objects. The tendon-driven architecture is more aligned with this function than complex linkages or direct actuator drives found in many industrial robots. More importantly, this mechanical hand, including both hardware and software, is completely open source. They market it at the symbolic price of $314, approximating $C pi dollar, aiming to accelerate the ecosystem through community contributions.
Since we're talking about hands, I have a practical question. Does a humanoid hand absolutely need to mimic the human 5 fingers? I remember many movie robots have 3 or 4 fingers. Is 3 enough for gripping tasks?
That is a great question. Evan's answer is that for basic pick-and-place tasks, a tripod support 3-finger grasp is totally enough. However, the situation changes when you involve tool operation, such as picking up and using a vacuum or a screwdriver tools with a handle and a trigger.
Ah, I get it. You need at least 3 fingers to hold the handle securely, and then another finger to pull the trigger.
Exactly. Evan believes you definitely need 4 fingers. 4 fingers to hold the tool, and the index finger to pull the trigger. Stability in holding and actuating the trigger drops significantly with just 3 fingers. This reiterates Professor Yan's point. The foremost principle in robotics is to be specific about the task you're trying to accomplish. Form factor is always a function of the task. Now, we arrive at the most critical main thread of this episode. The 3 panelists unanimously agree that the bottleneck hindering mass robot adoption is no longer a single technical difficulty, but rather the operational, financial, and legal challenges surrounding real-world deployment.
Real-world challenges. Are we talking about the kind of problems where robots work fine in the lab but fail the minute they step into a real environment?
Yes, the number one pain point is reliability and uptime. Investor Anand bluntly complains that robots break down all the bloody time. Out of tens of thousands deployed, there are always broken robots at any given time. So, they are now hiring and training thousands of veterans as robot technicians to ensure field maintenance and repair capabilities.
Wait! After billions of dollars in R&D, the operational bottleneck is the need to send people for on-site repair. That sounds like we've regressed to the Industrial Revolution, just replacing factory workers with robot technicians. How difficult is this reliability problem to solve?
It is a systemic issue. The maturity of a bipedal robot requires the improvement of the entire system, from perception to execution. A minor fault in any link can lead to downtime. Even if the hardware issue is resolved, Professor Yan shared a minor everyday pain point: the robot's cooling fan noise and the loud clunk 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 sound when walking on hardwood floors. These details directly impact user experience and acceptance. Besides reliability, the second major bottleneck is money, specifically deployment capital. A robot might cost $50,000, but customers are unwilling to pay up front. They are more accustomed to an operating expense (OPEX) model, paying monthly, perhaps $1,000 a month.
That makes sense. Clients are used to paying monthly for software or services. But how do robot companies bridge this contradiction?
The contradiction lies here. When a robot company secures a large order, say 500 robots worth $10 million, they face a huge capital gap. Traditional VC equity is too expensive, and bank loan interest rates, like Silicon Valley Bank, are too high. Anand solution: a consortium of 18 different banks establishing an $800 million fund.
$800 million! So, what is the function of this fund?
This fund underwrites the end customer contract at a lower interest rate, around 3 to 4%. Essentially, it provides a low-cost financing channel for robot companies, large-scale procurement and deployment, thus solving the capital bottleneck they face during scaling up. They turn a technological hurdle into a manageable financial problem.
We've discussed operations and finance. Finally, there is a big picture issue: trust for robots to enter homes, hospitals, and industrial defense sectors en masse. People must trust them. How is Silicon Valley addressing liability and data security?
First, liability insurance. Professor Yan pointed out that legal liability for deploying robots in the home is a practical barrier, But the positive news is that insurers like Munich Re have begun offering AI Shore insurance, covering liability resulting from the robot's failure to perform a task.
Legal liability can be covered by insurance, but what about data security and trust? Especially concerning LLMs and robots from certain international manufacturers, is there fear of backdoors and privacy risks?
Absolutely, especially in industrial and defense sectors where security clearance is a huge obstacle. The solution is the open source mindset. Professor Yan emphasizes that transparency is the basis of trust. Open source allows users and regulators to look into the brain of the thinking machines, understanding where data flows, thus eliminating concerns about backdoors, data security, and privacy. This is not just an ethical consideration, it is a crucial market access strategy. To summarize Silicon Valley, S core insights on robotics. Today, S discussion shows us that the future of robotics is not a purely technical race, but a multi-dimensional system war of business, operation, and trust. We draw 3 key conclusions. 1. Form is function of ROI. Whether universal humanoid or task-specific, the ultimate choice depends on its ability to reliably solve big enough, meaningful enough problems in enterprises and achieve a rapid return on investment. 2. Bottleneck is uptime, not tech. The biggest current challenge is reliability, ensuring the robot's uptime, which necessitates a robust field service network and operational system. 3. Capital and trust are dual accelerators. Robot companies must establish low-cost deployment funds to bridge the capital gap and build social trust through open source and software transparency to overcome legal and data security barriers.
This panel discussion brings us back from sci-fi imagination to commercial reality. Robots must not only be able to walk, see, and talk, but also be stable, profitable, and worthy of our trust. Thank you, Laurie, for the insightful analysis, and thank you to all our listeners for tuning in.